Okay, this time let's do a little bit of a harder problem. Here we've got a code snippet that's made of two parts. So our precondition is that x is greater than or equal to 0. And what does the code do? It adds 3 to x, and then afterwards doubles x. And we want to guarantee afterwards that x is greater than or equal to 6. I haven't solved this problem before, so maybe I might make some mistakes, and maybe it's worth watching how I would go about to solve these problems. So the first thing I do is I see 2 bits of code. I know the only way to solve this problem is to use the sequencing rule. So I'm going to do the sequencing rule backwards. So this here is my predicate P. This is S1. This is S2. And this is R. So I'm going to have to prove 2 statements for some yet unknown predicate Q. So I have to prove both that x is greater than or equal to 0, and you add 3 to the result. Therefore, some statement Q, I have to work out what Q is in a moment. And then for that same Q, if you double it, 2 times x, then x is greater than or equal to 6. Okay? How can I figure out what Q is? One way to do that is to do assignment backwards on the second statement here. So if I had x is greater than or equal to 6, and in the statement Q, all 2 times x's were replaced with x, what would Q have to be to make this a valid assignment? So it's going to have 2 times x's in it, and replace the 2 times x's with x to get x is greater than or equal to 6. So it looks like it's going to have to be 2 times x is greater than or equal to 6. So I replace 2 times x with x. There we go. This is a valid form of the assignment rule. Therefore, the predicate here has to be the same choice as predicate as the predicate here. So this is going to have to be 2 times x is greater than or equal to 6. Okay? Now, if I want to prove this rule, I'm going to either have to do an assignment or one of my 2 precondition strengthening or postcondition weakening rules. So first off, if we look at this, is this a valid form of the assignment rule? Replace all x plus 3's on the left with x's on the right. Doesn't look like it because there aren't any x plus 3's on the left hand side. So one thing you can do is copy the statement above. So I'm going to move this up here. So what do we have? We have 2 times x greater than or equal to 6. Copy my post condition. Copy my code. X is assigned to be x plus 3. And then I can do the assignment rule backwards. So the x's will be replaced with e's to get the precondition on the left-hand side. Here, my x's is just x, and my e's are x plus 3. So I'm going to have, instead of x, I'm going to have x plus 3 on this side. So it's going to be 2 times x plus 3 is greater than or equal to 6 as my precondition. Replace x plus 3's with x's, and I get 2 times x is greater than or equal to 6 as my postcondition. So this is also true by the assignment rule. Now I just got to get from here down to here. The only thing that's changed is the precondition. So hopefully x is greater than or equal to 0 is a stronger precondition than this precondition up here. So if I have x is greater than or equal to 0, well, that implies x plus 3 is greater than or equal to 3, which implies 2 times x plus 3 is greater than or equal to 6. So we can scrub out this middle bit and declare if x is greater than or equal to 0, then 2 times x plus 3 is greater than or equal to 6. So this is indeed a stronger precondition. So this is my logic. Put my line numbers in. Line number 3, we got from precondition strengthening. Preconstr, lines 1 and lines 2. Line number 4 is a valid form of the assignment rule. And then how do we get to 5? Well, here's my predicate P, the first bit of code Q. Here's the same Q, second bit of code, and then R. Therefore, I can use the sequencing rule to stitch these 2 things together. So the last line here will be sequencing by 3 and 4. Okay? Working backwards like this is a really good way to prove these sort of problems. Because if you look at the top, how on earth would I have known to make that assignment? Well, I have no idea, right? The only way I worked that out is sort of working backwards and trying to figure out what I need and then I can sort of do assignment either on the post condition or on the precondition to get this statement here, and then either weaken the post or strengthen the pre to sort of get what I want. So you sort of work backwards up and then get something that's an assignment, and then try and connect the gap in the middle. This is by far the easiest way to prove these sort of problems.